Welcome to the CSEC Physics Masters YouTube channel, the channel that will allow you to master CSEC physics by taking the subject topic by topic. The topic that we'll be looking at today is scientific notation, otherwise called standard form, and it is a very important topic as it is one of the foundations of understanding CSEC physics. Please remember to like, share and subscribe to this channel, and to click that notification bell so that you can get these videos as soon as they are posted. Nature is composed of very intricate mechanisms, and scientists who try to define and describe these mechanisms would oftentimes encounter very large and or extremely small numbers. Numbers that prove to be very impractical to represent in their decimal form, especially when performing complex calculations. This is where scientific notation or standard form takes the stage. Take a good look at this number. This is a number for the mass of an electron in kilograms, and it is represented here in decimal form. Imagine if you had to use this number and substitute it into equations in order to solve them. How difficult would that be? However, this long number, when represented in standard form, gives you 9.11 times 10 to the negative 31 kilograms. What you can see is that in standard form you get a more compressed value, one that is much easier to work with, and one that will make the greatest difference when performing lengthy calculations. Whenever you're converting from decimal to standard form, the first thing you have to do is to move the point from wherever it is found within that decimal number and place it behind the first single digit non-zero value. In this case, it will go behind the 9 to become 9.11. The next thing to do is to put a times 10 behind that 9.11. Since when representing numbers in standard form, we always multiply that number by 10 raised to a power. After which you have to go back to your decimal number and check the number of times the point had to jump in order to reach behind that first single digit non-zero value. In this case, the point had to jump 31 times to get behind the 9. As a result, the power that will be placed over your 10 will be 31. Henceforth, your number now becomes 9.11 times 10 to the 31. Now, if the decimal number you're working with started with a 0, the power will take a negative value. In this case, the number becomes 9.11 times 10 to the negative 31 because the decimal number started with a 0. However, if the number that you started with did not begin with a 0, then the power will remain positive. Take a look at this other example. This is a number for the Avogadro's constant in both decimal and standard form. In order to convert it from decimal to standard form, the point will have to jump 3, 6, 9, 12, 15, 18, 21 times over all those zeros and 2 more times in order to get behind the 6. So in essence, the point had to jump 23 times in order to get behind the 6, which is the first single digit non-zero value. As a result of this, the 10 has been raised to a power of 23. As you can see, the number of times the point jumps determines the exponent that will be raised over the 10. So your Avogadro's number in standard form is 6.02 times 10 to the 23rd. The power remains positive because the decimal number that you started with did not start with a 0.